Okay, let's get started. So there's 7.3 complex numbers. They want us to plot polar coordinates. So basically, there are real numbers combined with imaginary components or the I components. We also call these complex numbers. So the vertical is the imaginary or complex part. Horizontal is the real part. Okay, so 6 minus I, well, what would that be? Right? This is 6 on the real number and -1 on the I. It's imaginary 1 right there. So you go to the 6 and then you go down 1. This right here is 6 negative I. So think of it as 6 -1. Now, this guy, part B, is -4, 8. So you'd go to -4 on the real, which is over here, and then up 8 up here. So essentially, this is like the x part. The real number part is the x kind of. Imaginary part is the y part here. So just like we used to do x and y, we have real and complex or imaginary. So -4 and 8i. That's why it's here. Positive 8, right? Going up 8 to the left 4. But anyway, it's pretty straightforward, right? So let's do one more of these. Back to the question, or I guess we can just do it here. Okay, so where was I? Yeah, so for the first one, 6 -I, you would just put 6, and then the coefficient of the I, -1. That would be the first point. Plot another one. -4 and 8 would be -4 plus 8i would be -4, 8, and that's it. Nothing crazy. Let's go to the next one. Yeah, this next one, it looks complicated, but it's really not. You're just using this formula here. Okay, so if they say 3 cosine, look at part A, 3 cosine 315 plus I sine 315. Just plug it into your, or actually just look it up on your circle, and you'll end up getting just this. Okay, so let's go through it together, right? If you look it up on your circle, you're gonna get this for the 315 cosine and this for the 315 sine. Then after that, you just distribute the 3 onto both, right? That's where these came from. Make it a little pretty, put the 3 in there. That's where that came from. Same thing here. And that's it. This is the transformation to trig form to standard form. Okay. It's the same thing on part B. Cosine 3 pi over 2 and I sine 3 pi over 2. Again, plug it into your calculator. That'll be 0 for this one right here. Oh, sorry, not calculator. Unit circle is better. Find this on unit circle. And that's it. You're going to have -6i left because the other one is 0. So going from trig to, what do they call it? Trig form to complex number form. It's pretty easy. You just kind of look it up on the circle, plug it in. Okay. All right. Let's do another one. Okay. So we're going to change now. This is a little harder. It's more work going from polar or the complex number into trig form. Okay, so complex to polar, that's what we're saying. So remember that when they give you a problem, A is the real number part, B is the complex part. Okay, so we have an A for -4 and then -4 √3 for the B. So the formulas we're going to need are going to be these guys here. This one to get the R and this one to get the theta. Because to get to polar form using this right here, we need the R, we need the theta. So to find it, we have to do this work here and here. So we'll do that in just a minute. The only thing is I need you to know is that there's different ways to find R depending on where A and B are located. So you should plot the uh, okay, so what was I lost my train of thought. Yeah, so plot your what you're given. So -4 is the real part, so that would be out here. And then -4 √3. So you're going to get that. You're going to use a calculator for this. Get some decimal. That's about 7, not quite. And it's so now we know it's in quadrant 3, and we can find the length by doing the R, finding R if we want, if we need to. But since it's in quadrant 3, we gotta follow this formula here. So it says if it's 2 or 3, use this one. If it's 4, use that one. So pretty easy. Almost all are the same. Data changes a little bit. Let's scroll up here. If it's quadrant 1, it's just straight up these formulas. If it's quadrant 2 or 3, this one does not change, but theta, you have to add pi to it. Since we are in quadrant 3, we're going to add pi. Yeah, there you go. So that's what we're going to do. So since z equal to -4 minus 4 square root 3i is in quadrant 3, then use the formulas above. So I recommend writing down all those formulas for the different scenarios. Okay. All right, so here we go. R is equal to the square root of -4 squared plus -4 √3 squared. So that'll be 16 plus 16 times 3. What is that? 48. 16 plus 48 is 64, which is 8. Okay, so there is R. Now find theta. We're going to do tan inverse of B over A. Remember, B is this part, the imaginary coefficient, and A is 4. Oops, that'll be positive, double negative. Okay. Oops, don't forget plus pi. So make sure you're in radians or change it to 180. So that will be √3 plus pi. So pi, this calculator, the unit circle would be pi thirds for this. Add your pi, do your fractions, and you're gonna get 4 pi thirds. So now that I have both, I can change to polar form. So z equal to -4 minus 4 root 3 is equal to 8 cosine of 4 pi thirds plus I sine 4 pi thirds. So this is what they want. Okay. So anyway, so that's what you get to polar from complex numbers. Let's do another one. Okay. So we're going to do multiplying of division of trig form or polar form numbers. Okay, so if they're giving you Z1 and Z2, if you want to divide or multiply, you got to follow these formulas down here. So all you got to do is plug everything in and we're good. So I'm going to do division first. So I'm going to do this on paper and then I'm going to do this one on part B. Okay, so division says R1 over R2 cosine of theta 1 minus theta 2 plus I sine of theta 1 minus theta 2, same thing. Okay. So that will be 10 over 4 times cosine of 10 minus 160 Okay. So there's the division. Now just simplify and then you'll be good. This will be 5 halves. Let's put brackets for this one. Cosine of negative 150 plus I sine of negative 150. Use your oops. Use your um, even and odd properties to get rid of those negatives in there. That'll be negatives are absorbed by cosine because it's even. So it's just the same as this. This negative comes out in front. That's the odd property. And that's it. There we go. In polar form. So now part B says do the times. So the formula is, let me write it down for you just in case. The R1 times R2 cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. So theta 1 is from the first Z1 and theta 2 is from the second Z2 here. Okay, so that'll be 10 times 4. Right, let's do a bracket this time. Cosine of 10 plus 150 plus I sine of 10 degrees plus 150 degrees giving us 40 cosine of 160 plus I sine 160. Okay, so that's you fixed my error here. This is supposed to be 160, not 150. So 10 plus 160, 10 plus 160, it's going to be 170. And this will be our final answer. But yeah, that's all. Just follow these two formulas. This guy and then the division. Move on to something else. Okay, this next one is another really just using a formula kind of problem. So let's not waste too much time. So just identify what is what, right? So remember this is the R. This is obviously theta. This guy, the 6, is going to be the N. So if you understand all that, just plug them in here and understand that well. Instead of raising the entire thing to the 6th power, I can just move this power, the 6, onto the R. So check it out. So instead of doing all this ugly nonsense, so like multiplying all this garbage, like, you know what? I'm just gonna move this guy onto the 4. Now notice this doesn't have any power. It's just a normal cosine plus I sine stuff. So the only thing that really changes from the beginning is the 4 and the angle, because I forgot that this n has to be on the theta as well. So you put the 6 there and you multiply it on the angle here and here. So 6 times 3 is 18. That's where this came from, right? 6 times 3 again is 18. And that's it. Honestly, all we did was we started with this. We put this 6 power here and here and here. And we're done. Just multiply stuff out. So we change this guy into this by using this formula here. So just make sure you have this written down somewhere, and you'll be able to do this. Okay, so that's pretty much it for this section. 7.3.